Hello, Algebra 1. I hope you guys are having a wonderful day today. Today we're going to be looking at factoring trinomials when a is not equal to 1. In the previous lesson, we factored trinomials when a is equal to 1. For example, if you look at number 1 right here, this would be a problem where a equals to 1. But if you look at the problems below that, we're going to be dealing with problems where a is not equal to 1, right? In number 2, we have a 2 there, and for number 3, we do have a 3. And so when we factor trinomials when a is not equal to 1, you'll notice it is similar to what we did in the previous lesson, but there will be some more places where you have to be extra careful, okay? So let's go right into number 1. If you remember, the way we did this was we created a Punnett Square, which represents our algebra tiles, right? On the top left, we put the x squareds. On the bottom right, we would put the 24, right? Those individual ones tiles. And then from there, we need to figure out how many rectangles, right, we would put along the diagonals. Those are your x's. And so the way we did that was we created this x box problem where we said the top number was 24 because there's 24s right here, right? And then we said that the bottom number was 10. And the reason why it's 10 is because all we have to do is take this number here, the middle term, and look at the coefficient. But I kind of cheated because technically to get this 24, what I should have done was I should have taken the number in front of x squared, right, which is a 1, and I should have multiplied 1 and 24. If I multiplied 1 and 24, then that would give me 24. But the reason why I skipped that step is because when a is equal to 1 times any number is just that number. So I just kind of skipped that step. But technically, I should have multiplied 1 and 24. Now from here, we're going to figure out what two numbers multiplied to 24 add up to 10. If you guessed 4 and 6, you got it right. Then we would put the 4x's here and the 6x's here. It doesn't matter where you put the 4x and the 6x, right? And then we figured out that this first box, right, would have to be x times x. That gives me x squared. And then we asked ourselves x times what gives me 4x? Positive 4. X times what gives me 6x? Positive 6. And then just as a little way to check, 6 times 4 is 24. And that's nice, right, when that works out. And then from there, when we wrote down our final answer, we just took the dimensions of this Punnett square, right? So here my width is x plus 6. My length is x plus 4. And this was my final answer. How did I get that x plus 6? That was right here, right? And the x plus 4 was right here, okay? So hopefully this is a review of what we did before, right? Now let's look at number 2 when a is not equal to 1, and you'll see how this problem becomes slightly more complicated. First thing, let's create this Punnett square. The top left will still be where your x squared terms go. Here we have 2 of them, right? So 2x squared. On the bottom right, that's where we're going to put the plus 3. And once again, we want to figure out how many x's I need to put along the diagonal. And so we want to create this x box, right? Where the top is the product, the bottom is the sum. So what we need to do here is we need to take the number in front and the number at the end, and you want to multiply these together, okay? So you want to multiply 2 times 3, and you get 6. And that's the number you want to put on the top. Now from there, what you want to do next is you want to figure out what number goes on the bottom, and that's going to be your 5. So again, that never changes, right? All we did was we looked at the fact that this 5 corresponds with this 5 here. And then from there, we would figure out what two numbers multiply to 6 and add up to 5. If you guessed 2 and 3, you were correct. We would put 2x here and 3x here. And now this is where things get a little bit trickier. Because in the previous example, I knew that this was going to be x and x, right? Like that was nice because x times x is x squared. But if you look here, I have a couple different options for what can multiply to 2x squared. Right? I can put 2x here and I could put x here. Or maybe instead, I'll put x here and 2x here, right? So I have a couple different options. So the question is, which one goes where? The way we're going to do that is by picking a row or column and finding the GCF. So for example, I'm going to choose this first row here, okay? What I'm going to do is I'm going to look at the two terms, 2x squared and 3x. I'm going to ask myself, what is the greatest common factor? In this case, it would just be x. There's no number that goes into both 2 and 3 aside from 1, so my greatest common factor will just be 1x or just x. Now from there, you're going to fill out the times table, right? X times what gives me 2x squared? X times 2x gives me 2x squared. X times what gives me 3x plus 3. 2x times what gives me 2x plus 1. And then just to check, right? If you do x times 3, or sorry, 1 times 3, you do get 3, and that does work out. And so when you write down your final answer, you're going to take the dimensions, right? X plus 1, 2x plus 3, and this would be your final answer. So the tricky part will be when you're trying to do this part here. When you're trying to figure out what goes here and here, that's going to require a little bit more planning because you want to look for the greatest common factor and use that. By the way, if you notice this 2x right here, this 2x, right? That's the greatest common factor of this column, huh? So you could pick any row or column and find the GCF, okay? Let's look at another example. For number 3, just like we did before, we're going to create another Punnett square. Here, I'm going to put the a squared term on the top left. Here, I'm going to put plus 2 on the bottom right. And just like before, how many a's should go along the diagonal? So we need to create an x box, right? Top is the product, bottom is the sum. To figure out what number goes on top, you want to take the first number here and the last number, and you want to make sure you multiply these together. 3 times 2 just happens to be 6 again, right? The bottom number is going to be 7, and how I got that was simply by looking at the middle term and looking at the coefficient. From there, we're going to ask ourselves what two numbers multiply to 6 and add up to 7. If you said 6 and 1, that was correct. You take those numbers 6 and 1 and you're going to put it in the bottom left and the top right boxes, right? And then from here, you're going to try to factor out the GCF, picking a row or column. What I'm going to do here is I'm going to look at this first column, okay? And I'm going to look at the GCF, right? What's the greatest common factor that goes into both 3a squared and 6a? Well, first, let's look at the numbers, right? What's the greatest common factor for 3 and 6? Just 3, right? What's the greatest common factor of a squared and a? Just a. 3a would be my GCF. And then from there, you want to figure out 3a times what gives me 3a squared? It would be a. It doesn't matter what order you do at this point, right? A times what gives me 1a plus 1, right? 3a times what gives me 6a? Positive 2. And so your final answer here would just be a plus 2, 3a plus 1. And this is your final answer. Hopefully you're getting the hang of how to factor trinomials when a is not equal to 1. Just like before, when the video says your turn, I want you to pause the video, try the problem on your own, and then press play when you're ready. So whenever you're ready, try number 4. So let's see how we did for number 4. Hopefully you created your Punnett square, where you put the x squared terms on the top left, so you have 3 of those, right? On the bottom right, you would put the minus 10. And then to figure out what goes in the diagonals there, we're going to make another x box, right? Top being the product, the bottom being the sum. Hopefully what you did was you took the number in the front and the number at the end, and you multiplied 3 and negative 10 together. And if you did, you got negative 30, right? And then to figure out the bottom number, you would put negative 1. Now here you have to be very careful because when you look at this middle term here, right? You see just a negative with an x, right? But whenever there's no number there, you need to put a 1, right? That's the coefficient. So in this case, the coefficient is really a negative 1. And so here we put a negative 1 on the bottom. Then we're going to ask ourselves what two numbers multiply to negative 30 and add up to negative 1. Here it would be negative 6 and positive 5. So what that tells me is that I'm going to have negative 6x here, and I'm going to have 5x here. Hopefully you got it up to this point, but we still have a ways to go, right? What I'm going to do next is I'm going to pick a row or a column. It doesn't matter. Here I'm going to pick this first row. And I'm going to ask myself, what is the greatest common factor? Now, when you look at the numbers 3 and 5, the greatest common factor is just 1, right? When you look at x squared and x, the greatest common factor is x. So my GCF is 1x, or simply just x. And then from there, we're going to complete the times table. X times what gives me 3x squared? 3x. By the way, if you look at this 3x right here, right? Isn't this 3x the greatest common factor of this column? If you look at 3x squared and negative 6x, isn't 3x your GCF? So that's why it doesn't matter which row or column you pick. As long as you do it carefully, you'll get the right answer in the end. X times what gives me 5x, right? Plus 5. 3x times what gives me negative 6x? Negative 2. And just as a quick way to check, negative 2 times positive 5 does give me negative 10. That's great. Your final answer then will be x minus 2, 3x plus 5. And this is your final answer. How did you do? Did you make any mistakes? Be very careful because there's a lot more steps going on, but it's very similar to what we did in the previous lesson, right? We're going to do one last example for today. I want to see if you can get this correct on your own. Creating a Punnett Square, putting 7b squared on the top left and putting positive 4 on the bottom right. We're going to create our Xbox problem where the top is the product and the bottom is the sum. Now what we want to do next is we want to multiply the last number and the first number. So when you multiply 7 times 4, you should get 28, and that's the number that goes on top, right? Then we want to figure out what's the number that goes on the bottom, and that's going to be negative 16 in this case, because you're going to look at the number here in the middle term, right? The coefficient in the middle term, and that's negative 16. And then from there, we're going to ask ourselves what two numbers multiply to 28 and add up to negative 16. So we know that both numbers have to be negative because the product is positive and the sum is negative. If you said negative 14 and negative 2, then you were correct. So now we're going to put negative 14b on the bottom left. We're going to put negative 2b on the top right. And then from there, we're going to pick any row or column and then look for the GCF. So for this one, I'm going to pick the first column. Okay. I'm going to look at the two terms, 7b squared and negative 14b, and I'm going to try to figure out what the GCF is. Let's just start with the numbers first. Let's look at the 7 and the negative 14. What's the greatest common factor? A positive 7. Now look at the variables, b squared and b. What's the greatest common factor there? It would just be b. From there, we're going to make a times table, right? 7b times what gives me 7b squared? It should be b. B times what gives me negative 2b? Minus 2. 7b times what gives me negative 14b? Also happens to be minus 2. And just as a quick little check, if I do negative 2 times negative 2, I do get positive 4, which is really nice. So when you write down your final answer now, you're going to write b minus 2 and then 7b minus 2. And this would be my final answer. So hopefully you see how this is similar to what we did when we factored trinomials when a is equal to 1. But it becomes a little bit trickier when you're trying to figure out what goes here and what goes here, right? That's where you have to pick a row or column and look for the greatest common factor. Make sure you guys review your notes before you try your homework, and I hope it goes well.